Welcome to Lesson 23, Problem 3, and we are adding and subtracting rational expressions. And remember, they're just like any fractions. We need a common denominator to add or subtract. So there is a good hint here. Factor the denominators when possible. So these problems are going to take quite a bit of work. So I'm going to zoom in so you can see it pretty well. Let's start with 3a. I'm going to start by factoring 3k over k minus 5 and k plus 5. So k minus 5 times k plus 5. And then we have minus 2k over k minus 5. I'm going to put that in parentheses too, just to make everything look the same. And we don't have a common denominator right now because the second fraction is missing a k plus 5. So I'm going to put in a k plus 5 in the denominator, so now they are common denominators. But if I do it to the denominator, I have to do it to the numerator because basically what I'm doing is multiplying the original red fraction by a very fancy version of 1 because k plus 5 over k plus 5 is just 1. And now I have a common denominator. So now I have 3k minus 2k times the quantity k plus 5 all over the common denominator of k minus 5 and k plus 5. And only a couple more steps. Now we have 3k minus 2k squared, because I'm distributing that negative 2k or the 2k and it's going to be subtraction. So, and then make sure you get a minus 10k there. And it's all over k minus 5 and k plus 5. So now we can combine the 3k and the negative 10k, and our final answer is going to be, I'm going to put it in descending order, 2k squared, negative 2k squared, minus 7k, all over k minus 5 and k plus 5. Great. Okay, let's go to B, another tough problem. In fact, B is a light bulb, so it is a really challenging problem, but let's do it. We're going to take that hint and we're first going to factor the denominators. So we know it's just an AM problem. In fact, it can be written, it's a perfect square trinomial. So we can just write it as x minus 4, the quantity squared, plus 2x over, and this is just an AM, where it has to add to negative 3 and multiply to negative 4. The two numbers are going to be x minus 4 and x plus 1. So, or the two numbers are negative 4 and 1. So we can factor it like that. Okay, so now we have to look at each of the denominators, and it seems to me like we have something in common. There's an x minus 4 in both fractions. But the fraction on the left needs an x plus 1. So I'm going to put an x plus 1 in the numerator, and I'm going to put an x plus 1 in the denominator. The reason I can do that is I'm multiplying by a very fancy version of 1. I'm going to do the same thing to the second fraction. I'm going to put an x minus 4 in the numerator and an x minus 4 in the denominator. Just multiplying by a very, very fancy version of 1. Okay, we don't change the value of the fractions. We're just changing the form. So now I have common denominators. So they both are the same, and I can just add right across now. So I have 4 times the quantity x plus 1 plus 2x times the quantity x minus 4 all over x minus 4, the quantity squared, times x plus 1. All right, great. So now let's distribute. We have 4x plus 4 plus 2x squared minus 8x. Okay, and that is all still over our common denominator of x minus 4, the quantity squared, times x plus 1. All right, now we're just going to combine our terms that are like in the numerator and write it in descending order for our final answer. So we have 2x squared, and then the 4x and the negative 8x is going to give us minus 4x plus 4 all over x minus 4, the quantity squared, and x plus 1. You could try factoring the numerator, but I can tell you it is not going to factor and cancel with anything in the denominator. So this answer is totally an appropriate way to leave your final answer. Okay, let's just zoom back into the original screen so that you can easily see both of the answers together. Thanks for joining us here today at Engage Math.